704 people. That is one of the lowest estimates scientists have ever calculated for the total number of humans alive at a single moment in prehistory. Not 700,000, not 700 million. 704 individual human beings standing between our species and permanent total extinction. Somewhere around 70,000 years ago, after the Toba supervolcano erupted and darkened the atmosphere across the entire planet, humanity may have contracted to a population smaller than a single city block. Every language that was ever spoken, every civilization that ever rose and fell, every war, every prayer, every child born into the modern world, all of it may trace back to a tiny, desperate group of survivors clinging to the southern edge of Africa while volcanic winter swallowed the sky above them. And the deeper that scientists investigate ancient DNA, Ice Age climate records, and the fossil bones of extinct human species, the more unsettling that story becomes. Because the question is no longer simply why humans evolved. The real question, the one that keeps researchers awake, is why humans survived at all, when almost every other human species that ever walked this earth vanished without descendants. Before we go further, tell us where you are watching from tonight, and tell us something else. What do you think actually kept our lineage alive? Was it intelligence, fire, the ability to cooperate across large groups? Or was survival itself nothing more than an accident, balanced for thousands of years on the absolute edge of collapse? Tonight, we are not looking at evolution as a story of progress. We are looking at it as a survival system operating under conditions of extreme, sustained pressure. A fragile chain of biological gambles, climate catastrophes, inherited memory, and social bonds stretching across millions of years. And at almost every point in that chain, humanity came terrifyingly close to disappearing forever. For most of human history, people imagined evolution as a ladder, one creature replacing another, one species climbing upward towards some inevitable superiority. But nature does not build ladders, it builds branches, and branches do not replace each other. They diverge, they split, and they survive or collapse entirely on their own terms. Somewhere deep in prehistoric time, more than 20 million years ago, ancient primates were moving through dense African forests without the slightest awareness that their descendants would one day fracture into radically different experiments in survival. One branch stayed in the canopy and refined itself into the extraordinary diversity of modern monkeys. Another drifted slowly toward the great apes, and one small, vulnerable lineage would eventually be pushed beyond the forest edge into a world it was never built for. The monkeys did not fail. This is essential to understand. Modern monkeys are not primitive humans that evolution left behind. They are the survivors of one of the most successful ecological systems in primate history, refined across tens of millions of years. They mastered seasonal fruit cycles, complex social hierarchies, warning call systems, and three-dimensional movement through forest canopy with astonishing precision. Today, more than 150 species of Old World monkeys are alive across Africa and Asia. Their system worked, and it is still working. Ours almost did not. Because the ape lineages faced a catastrophe that the monkeys, deeply integrated into the forest system, were far better positioned to survive. Climate instability began fragmenting forests across Africa and Eurasia. Rainfall patterns shifted, temperatures cooled. The great continuous canopy that had once stretched across enormous regions began fracturing into isolated woodland islands, surrounded by expanding grasslands. And for a tree-dependent ape population with no fallback system, this was not environmental change. It was extinction pressure arriving slowly enough to be invisible until it was nearly fatal. The Miocene fossil record is filled with vanished ape species whose worlds collapsed faster than their bodies could adapt. Most disappeared without any descendants. We nearly joined them. The Savanna did not welcome our ancestors. It hunted them. The creatures emerging from the shrinking forest margins between 4 and 7 million years ago were not designed for open ground. Their spines were still shaped for horizontal movement and climbing, Their feet retained the gripping architecture of arboreal life. Their bodies overheated rapidly under direct sun. Their movements across long, exposed distances were slow and energetically costly. And worst of all, they were visible. In the forest, survival meant escaping upward. On open ground, there was nowhere to disappear. The tall grass concealed predators that moved faster than anything our ancestors could outrun. Water sources were farther apart and harder to find. Reliable food became unpredictable in ways the forest canopy never was. Every crossing of open terrain carried a cost that could not be recovered if something went wrong. Under these conditions, evolution began reshaping the human body through a series of brutal compromises. Standing upright may have allowed early hominins to see above the grass, to carry food and infants across distances, and to travel between fragmented resources without overheating. But every adaptation brought consequences that persist in every human alive today. The vertically loaded spine introduced chronic structural failure that modern medicine still cannot fully correct. The narrowed, twisted pelvis made human childbirth one of the most dangerous deliveries of any primate on Earth. The grasping foot that once held branches transformed into an arched structure built for endurance, walking functional, but vulnerable to injury in ways that a quadruped's foot simply is not. Every elegant feature of the human body carries the signature of a survival crisis. We were not intelligently assembled. We were pressured into shape by environments that filtered out every configuration that could not survive long enough to reproduce. And even after all of that, upright walking alone could not save us. It only changed the nature of the world we were exposed to. The most important consequence of walking upright may not have been mobility at all. It was liberation. Once the hands were freed from the demands of locomotion, something that had never happened in the history of large-bodied animals began to unfold. For hundreds of millions of years, survival in the animal kingdom had depended almost entirely on anatomy. Claws, teeth, muscle, camouflage, venom, speed. Every creature that persisted did so because its body carried the tools it needed to survive. Human ancestors began doing something categorically different. They moved survival outside the body entirely. A sharp stone became an artificial tooth, capable of processing food that raw hands and jaw muscles could never handle. A thrown spear became artificial reach that extended effective predatory range beyond anything a biological arm could achieve. Animal hide became artificial fur that allowed survival in climates the naked human body could not otherwise tolerate. And fire, eventually, became artificial digestion, transforming the metabolic ceiling of the human lineage in ways that would take hundreds of thousands of years to fully understand. This is the hidden pattern beneath everything that followed. Human ancestors survived not because their bodies became perfectly suited to any single environment, but because their bodies became increasingly dependent on external systems that could be taught, inherited, and improved across generations. And that shift changed the entire nature of survival. A monkey must inherit its survival system almost entirely through biology, through body structure, through instinct, through genetic adaptation refined over vast timescales. A human child must inherit survival through teaching. Tool-making had to be demonstrated and remembered. Migration routes had to be communicated and preserved. Seasonal knowledge had to be passed forward with enough accuracy that the next generation could use it before the season arrived. Knowledge became infrastructure. And infrastructure is fragile in ways that bone and instinct are not. If one generation fails to transfer knowledge correctly, the next generation does not inherit wisdom. It inherits danger. For most animals, fire was catastrophe. Lightning struck dry grass, and the world fled. But somewhere in deep prehistory, no one knows exactly when or how human ancestors began approaching the thing that every other creature was built to escape. At first, perhaps only scavenging burned landscapes for cooked meat left behind by lightning strikes, then carrying embers, then protecting a flame through rain and wind. eventually building it deliberately. And once controlled fire became a reliable technology, the pace of human biological change appears to have accelerated in ways the fossil record is still revealing. Cooking fundamentally altered the metabolic architecture of the human body. When meat and root vegetables are exposed to sustained heat, proteins begin to break down and starches gelatinize before the food ever enters the digestive system. Calories become dramatically easier to absorb. The same food that required hours of raw processing now yielded far more energy for far less biological cost. Richard Wrangham's cooking hypothesis proposes that this transformation may have been the single most important driver of human brain expansion in the entire Pleistocene, because the human brain is extraordinarily expensive. Tissue. Today it consumes approximately 20% of our total metabolic energy, despite representing only a small fraction of body mass. A primate trying to sustain a brain of that scale entirely on raw food faces severe biological limits that cannot be overcome through anatomy alone. Cooking changed the equation. As the gut shrank and digestion became cheaper, more energy became available for neural tissue. The fire did not simply warm human bodies, it fed larger minds into existence. But fire transformed something beyond biology. It transformed time. Before controlled fire, darkness ended the day and activity ceased. After fire, humans gathered in illuminated spaces after sunset for the first time in evolutionary history. The evening became social territory, a place for memory, for planning, for teaching, for rehearsing knowledge that could not be lost. The campfire may have been the first true human network, and everything that came after it carries that ancient architecture forward. For most of prehistory, Homo sapiens was not alone on this planet. The Earth once supported multiple human species, simultaneously different evolutionary experiments unfolding across different environments, different climates, different ecological pressures. Neanderthals occupied Europe and Western Asia. Denisovans spread across Central and East Asia. Homo erectus persisted in parts of Southeast Asia long after modern humans had already appeared in Africa. Homo floresiensis survived on a single island in Indonesia. Homo naledi inhabited cave systems in southern Africa in ways that still are not fully understood. The Neanderthals in particular were not the primitive, brutish creatures that early 20th century science imagined them to be. They were Ice Age specialists, refined by hundreds of thousands of years of cold climate survival. Their compact bodies conserved heat efficiently. Their enormous muscle attachments allowed sustained physical intensity that modern humans cannot match. They hunted large game across brutally unstable glacial environments and persisted in Europe and Western Asia for over 300,000 years before Homo sapiens expanded out of Africa. Their system worked. And then it failed. What ancient DNA research led by Svante Pääbo and the team that earned the Nobel Prize in Physiology in 2022 revealed about that failure permanently changed the way scientists understand extinction. The Neanderthals did not simply disappear. Fragments of them survived. Between 1 and 4% of the DNA carried by many living humans today originated in Neanderthal populations who interbred with early modern humans during the periods of contact. Denisovan DNA persists too, particularly in populations across East Asia and Oceania. One specific Denisovan-derived genetic variant called EPAS, one still helps Tibetan populations process oxygen efficiently at extreme altitude, a survival adaptation from an extinct human species still functioning inside living. Human bodies tens of thousands of years after the people who first carried it were gone. Humanity is not a clean success story. We are a genetic archive of worlds that almost survived. Then came the moments when survival narrowed toward nothing. Genetic evidence drawn from modern human populations strongly suggests that our species passed through catastrophic population collapses during the late Pleistocene events so severe that they compressed human genetic diversity in ways still visible in DNA comparisons today. The Toba supervolcanic eruption, approximately 74,000 years ago, remains one of the leading candidates for the most extreme of these events. The eruption released enormous quantities of volcanic material into the atmosphere, dramatically reducing sunlight and collapsing temperatures across the planet. For human populations already surviving at the edges of ecological viability, the cascading consequences may have been devastating in ways that unfolded not over years, but over generations. Food chains destabilized, prey populations collapsed, rainfall patterns shifted across the regions where human groups had built their survival systems. And somewhere inside this period of catastrophic pressure, the total number of breeding humans may have contracted to only a few thousand individuals or, in some estimates, far fewer. The psychological reality of that world is almost impossible to hold in the mind. Small groups moving through cold, ash-dimmed landscapes, hunters returning empty-handed season after season, mothers protecting infants through conditions for which no inherited knowledge had prepared them. No one in those groups understood that they were the last. No one knew that the decisions made in a single season, which direction to move, which coastal resources to exploit, whether to stay or leave, might determine whether any humans at all survived into the following century. Archaeological evidence from sites like Pinnacle Point in South Africa, dated to precisely this period, suggests something remarkable. Rather than cultural collapse, the record shows rapid behavioral innovation, complex blade tools, systematic exploitation of marine food sources, and expanded resource flexibility precisely when conditions were most extreme. The populations that survived the bottleneck may have done so not because they were the strongest, but because they adapted their behavior faster than the environment could eliminate them. Somewhere between 100,000 and 40,000 years ago, the archaeological record changed in a way that still divides researchers, debating its exact timing and cause, but not its reality. Symbols began appearing in the record. Ochre pigments were processed and applied deliberately. Shells were traded across distances that required planning far beyond immediate need. Cave walls in France and Spain and Indonesia were marked with images of animals rendered with anatomical precision and compositional intention, images that required entering darkness deliberately, with carried light, to create something that no individual making them would ever fully see in the way a modern observer can. This was more than intelligence. Hominins had been intelligent for a very long time. This was symbolic thought operating at a new, functional scale, the capacity to hold an image of something inside the mind when the thing itself was completely absent. To represent not just what was present, but what was remembered, what was imagined, what was planned, and what was feared. For the first time in the history of life on Earth, a species was preserving experience outside the individual nervous system. A story could survive the death of the person who first told it. Knowledge could accumulate across generations without waiting for genetic inheritance to carry it forward. One hunter's failure became a lesson embedded in language and passed to people who had never made that mistake themselves. One successful adaptation could propagate across entire populations faster than evolution could ever move through DNA. Culture began evolving faster than biology, and that asymmetry may be the deepest explanation for why Homo sapiens expanded across every terrestrial environment on the planet deserts, Arctic tundra, island chains separated by open ocean, while every other human species that had survived hundreds of thousands of years before us eventually disappeared. We did not wait for bodies to adapt. We built the adaptation around the body and carried it forward in memory. Everything called civilization exists inside an unusually stable climatic window. The Holocene, the roughly 12,000-year period of relative environmental stability that followed the last glacial maximum, is not the default condition of this planet. The Pleistocene world that preceded it was violent, oscillating, and repeatedly interrupted by glacial cycles capable of transforming entire ecosystems within the span of human lifetimes. Agriculture became viable largely because seasonal patterns stabilized enough to make planting and harvest predictable. Cities emerged because surplus food systems became reliable enough to support populations that did not need to move. Every foundational structure of modern civilization was built on the assumption, rarely examined, that the climate producing it would continue to function within familiar parameters. Deep time offers no such guarantee. The Neanderthals survived over 300,000 years in one of the harshest environments our genus ever occupied, and then vanished within a geological instant of the expansion of modern humans into their range. Entire prehistoric human populations endured repeated glacial cycles, adapted across generations, built functioning survival systems, and then disappeared quietly from the genetic record without explanation. The pressures that shaped human evolution across millions of years did not disappear when agriculture began. They changed scale. Climate instability, resource disruption, ecological transformation, and population stress are not prehistoric forces. They are permanent features of a living planet that operates on timescales far longer than any civilization has ever lasted. The difference now is that one species has accumulated enough technological power to function as a geological force in its own right, reshaping atmospheric chemistry, altering ocean systems, and accelerating processes that would otherwise unfold across thousands of years into spans of decades. The same cognitive capacity that allowed human ancestors to survive the Pleistocene is now operating at a scale the Pleistocene never required it to manage. And the question of whether it is capable of operating at that scale accurately, collectively, and in time remains genuinely open. The monkey in the canopy and the human standing beneath it are not rivals. They never were. They are two surviving answers to the same evolutionary question: how do you remain alive in a world that continuously generates new conditions for which no existing system is fully prepared? The monkey answered by perfecting integration with a single, ancient, extraordinarily productive environment. We answered, or were forced to answer, by learning to carry the survival system itself, learning to store it in language, in tools, in ritual, in the accumulated teaching of one generation to the next, until the system became more flexible than any single environment could destroy. That may be the truest explanation for why Homo sapiens survived, when every other human species that shared this planet with us ultimately did not. Not because we were the strongest, not because our biology was superior, but because our survival system became distributed across entire groups in a way that no individual death, no single failed season, no isolated catastrophe could fully erase. The knowledge persisted even when the individuals carrying it were gone, and still nothing in that system guarantees permanence. Every person alive today exists because ancient humans maintained fragile survival chains through conditions that should, by any reasonable probability, have broken them entirely. A fire kept burning through a season of rain. A child carried across a landscape that had stopped producing food. A migration route remembered correctly by someone who had never traveled it themselves. A warning encoded in story and passed forward long enough to matter when the danger finally returned. You are the product of survival chains that came within reach of breaking more times than the fossil record can fully count. Inside your body are the genetic fragments of extinct human species who did not make it. Inside your mind are inherited cognitive systems older than any civilization that has ever existed. And somewhere, tonight, in forests that have been standing longer than our species has had language to describe them, monkeys are still moving through branches above the ground, where our own lineage once began its long, unlikely, unfinished journey. Not failed humans, not unfinished humans, just another branch of life that found its answer and held on. For now, if this kind of deep-time investigation into human extinction, ancient DNA, and the survival systems that shaped our species is the territory you want to keep exploring, stay with Prehistoric Shadows. Because the deeper we go into the origins of humanity, the clearer one truth becomes. Survival was never guaranteed. It was only ever temporary. And the distance between those two things is the entire history of what it means to be human.